Hey everyone, I'm Dan Bautista. Like Will said, I'm a data analyst here at the observatory. I've been here just over 2 years now. Um, I do a good amount of observing support on various GBT projects. I'm a project friend for several low frequency L-band and pulsar projects. And I also do a good amount of work on the National Radio Dynamic Zone project under NRAO's spectrum management.
Hi, I'm Jay Frothingham, they, them, or he, them pronouns. I'm also a data analyst here, so I do all of the same observer support work. I actually come from an engineering background, so I really love instrumentation, and my kind of primary focus at the observatory has been VLBI support, as well as helping out to schedule the telescope.
Cool. Now let's see if I'm able to access FastX. Otherwise, this will be a very interesting demonstration. Um, can you guys see my screen?
Yes.
Cool. So this is what FastX looks like for those of you that are able to access FastX. Hang on, it says screen sharing pause. Let me try sharing it again. Okay, so the way we access our observing tools is through the terminal interface. I will start off by showing you Astrid. Astrid is the main interface that you will use to prepare your observing scripts and submit them to the telescope. So to launch Astrid, you will type Astrid followed by an ampersand into the terminal. The ampersand is to allow you to run other programs once Astrid launches. And then we wait a minute for Astrid to launch. It will prompt you with this little window here asking you which mode you would like to use. For the demonstration, I will mainly work in offline, but when you are either monitoring or controlling the telescope, you will use one of the online modes. So for now, let's go with offline, and I will show you the basics of Astrid. So Astrid is this window that I have up. It has several different tabs that will allow you to either prepare an observing script or monitor the data coming in from the telescope as well as the telescope status. So first you will be using Astrid to edit or upload your observing scripts. And so to do that, you will navigate to your project either from this drop-down menu or just directly typing in your project code. So for this workshop, we will be using TGBT 25B underscore 608 and then hit enter, and that will take you to our observer training project area. For your projects that you'll be observing in the telescope, you will type in the same your project code instead of the one that I used. And then this column here will show you the list of scheduling blocks that have been saved for your project. So it looks like there's already a file in here that says README. These are directions that we recommend you following for when you guys write your own observing scripts later on in the workshop. And yeah, so to edit your script, you can simply just type into the text field. It runs on Python 2.7, so it has all of the logic that comes with Python, as well as some special GBT functions that allow you to tell the telescope what to do. So if I say print hello and then hit validate, I have a Python syntax error, and validating checks to make sure that your code is syntactically correct. So in this case, it threw an error at me saying you need to close your quotes. So closing it, validate, it will then go through your code and tell me that the observing script is syntactically correct. Then once you are satisfied with the state of your script, you will click Save to Database. And so I'm going to make up a file name for it, group 0 demo. And so now this file has been saved to our scheduling block area. And yeah, if you don't like working in the Astrid environment, you can also use the text editor of your choice to write your own observing script and then import it from a file. It will allow you to navigate your file system on the GBO computers, and then you can navigate to a file of your choice, select it, and open it. These are catalogs, so if we hit validate, they will give us errors, but this would also work if you had a observing script that you would like to use. I am not going to save this one, so save scheduling block to the database. Click no. That takes me back to the old script that I wrote. If I really like this observing script and want to save it for records, I can export to file, navigate to a directory, and then click save, and that will write the text from that script to that directory. We also have the delete from database, which if I decide that this test script is no longer needed, delete from database, and that will remove it. But let's not do that to other people's scripts. Also in this window, we have this text field down here, observation management log. In offline mode, it's not going to say anything. But if we are running in online mode, there will be updates from the GBT status that will be filling out here as our observations progress. Another important thing to be able to do is to switch from offline to online mode for editing to telescope control. So to do that, we will click the File drop-down menu. Second from the bottom, there is a tab that says Real-Time Mode. We select that, and that will open up the same box that opened up at the launch of Astrid. And so for this demo, we will work online, but monitor only. If you are going to be submitting your observing scripts because it is your turn to have telescope observations, you would select work online with control of the telescope. But for the purpose of the demonstration, we will work online monitor only. So now that we have switched to online mode, we get some information about the telescope. You see the telescope's observation state is idle, and the GBT is ready. There is usually a GBT status of error. That's usually not a urgent concern. There are a lot of systems that the telescope monitors, and something is usually complaining about it. We can look at what the cause of those messages are in the Cleo messages window that Jay will be showing us once I've finished with the Astrid. Now that we're connected to the telescope, we can look at the data display, and this will show us some diagnostic plots from the telescope. Most observations should start with a pointing focus correction, so those will generate some plots that ideally look like a nice Gaussian. That is going to allow telescope to add some final corrections to its pointing models and get us the pointed at the most sensitive part of the beam. There are also focus scans, which will also look like a Gaussian. Those are used for our Gregorian receivers. The prime focus receivers don't have enough range of motion in their hardware to really get us a good focus check, so those won't have focus scans typically. If you are using a higher frequency receiver, your observing setup will typically also require an auto OOF procedure. Those are additional correction terms to the telescope's active surface, in which they calculate Zernica coefficients for the dish, and I believe you'll be learning about that more in our high frequency focus corrections talk that will be later on in the workshop. There's also the continuum tab, which shows us a plot of the power versus time for our observation. And if we are observing in a spectral line mode, this would have a spectrum from your data displayed here. The telescope apparently was not observing in spectral lines, so in this case, our field is empty. The next tab we have is the GBT status. With this, you can take a look at a lot of the high-level parameters that tell you the status of the telescope. It'll tell us the observer, project ID, status, LST, various timestamps, where the telescope is pointing, where it's commanded to point, coordinates, corrections, scan status, weather, Vegas levels, and these you can all also find in various Cleo windows, but this is a good quick snapshot of the telescope status as a whole. So now that we have learned how to set up our observing scripts and check on the status of the telescope, next important thing is we want to be able to submit our scripts to the telescope to run our observations. So to do that, we would go back to the Observation Management tab, and below that there are another two tabs. One says Edit, the other says Run. For those, we would want to select the Run tab. That will take us to the menus that we will select our observing script and tell the telescope who's going to be in control. So we would navigate to our project, hit enter, and then since we have a scheduling block in here, it would appear this one is available. We could submit that to the telescope. It would just print hello, but this is where we would have a list of scheduling blocks to select from. We also have the session number. This should increment each time you observe on the telescope. Typically happens automatically, but it is always good to check with the operator. You would also then go to the drop-down menu and type in your name. So it may not let me because I am not in control of the telescope. There are many names, and it's pretty annoying to scroll through, so I'd recommend just typing in your name. And then you would also fill in the operator, the name of the operator on duty at the time. So to do that, you would log into Talk and Draw, say, hello, my name is Dan, I'm here for my observations. The operator will respond saying, hi, this is Rob on duty. The weather looks good, something along those lines. And then once you've filled out those fields, you would then select your scheduling block that you would like to submit. And if we were online with control of the telescope, these submit buttons would not be grayed out, and then we would select that, and it would go into the scan queue, the run queue, and the session history. And so you can queue multiple scripts. That's something that you can do if you know that you want to run several modular scripts in a row to prepare for your observation. And then session history would tell you when your scripts are submitted and in what order they were submitted. And then as your observation progresses, this log down here would fill up with information from the telescope. And at the end of your session, you would export it if you want to save that for your records. And I think that that's most of submitting. If for some reason during your observation you need to either interrupt or end your observation, these buttons right here would be dark. They wouldn't be grayed out, such as this, and that would give you the ability to pause your observation. That's going to just stop it at its current state, and it will not run until you unpause. We have stop, which stops the current subscan and interrupts the current scheduling block, offering the user a chance to exit. And then there is abort, which would prompt you to confirm that you want to abort. And if you click yes, it will just halt your observation right then. These would typically be something that you would use at the end of your observations. Once your time is up, you will need to stop your observations, so that way the next project scheduled can start getting prepared for theirs. The operators really do not enjoy having to stop your project for you, so let's all be nice to the operators and make sure that we keep track of the time for our observations. I think that's about everything. I think I will pass it off to Jay now.
Awesome. Thanks, Dan. I'm just going to put a quick link in the chat with further details on Astrid in case any of you want to look back at that later. And then I'm going to start sharing my screen, if I can.
Stop sharing.
Okay, cool. Can everyone see all right? Should be a nice picture of my cats.
Yes, I can see your cats.
Awesome. So I'm not using FastX for this demo just because we've been having the license issues, but to open up the applications that I'm going to be walking you through, you would just type Cleo, C-L-E-O, in the command line, just the same way that you would have opened Astrid. And once you do, you'll get a little launcher window that looks like this. And you can click Launch, or you can just click anywhere on the text Cleo, and it'll open the same little menu. And there are a lot of applications here. There's at least one application for pretty much every part of the telescope. But when you're actually observing and preparing scripts, you're only going to end up using a couple of them. So we're going to start out with Talk and Draw, because that is the most important application to have open while you're observing. So we're going to go to this Operator Tools menu, and we're going to click Talk and Draw. And it might take a second to boot. But this is how you'll communicate with the operator during your observations. You'll want to log on to Talk and Draw at least half an hour before your scheduled start time so that you can say hello to the operator. You know, if there's anything going on with the telescope, they would communicate with you there. So can we all see my Talk and Draw window? Alrighty. So right now this is blank, and that's because no one has sent a message in the last 30 seconds. But we can see a list of everyone who is logged on to the system right now. And I can see a couple of you guys are, as well as Dave, who is currently observing. Got a bug report related to Dan. Not sure what that's about. I haven't seen that before. So I'm going to ignore that for now. So to send a message in Talk and Draw, it's just like any other chat window. You would type, hello, Jay here for observer training And if I was observing, I would ask who the operator is. Now, I'm cheating a little bit. I know that it's Rob. And if you were observing, the operator would send a nice message back saying, hey, it's Rob, and confirming the time of your observation with you, usually. Now, there's these two checkboxes here, auto sound and auto raise. Auto sound isn't really going to do much because we can't transmit sound through FastX, but it's supposed to send, a chime or a beep or something whenever a new message pops up. What we do like to do is select auto raise. And what that'll do is it'll force this window to the front of your screen as soon as any messages come in. And that can be really useful if you're managing space on a laptop. Okay, we've got a message from Rob, GBT Ops. Hello Jay, having an azimuth motor controller issue at the moment, but it's being worked on. Thanks, Rob. Now, you might notice that this chat says all users, and that means that everyone who's logging on can see every single one of these messages. And usually that's fine, but again, I'm cheating a little bit. I've been in the control room. I know that every time a message comes in, there's a sound of a train horn going off in the control room. And we like to be nice to our operators, so we don't want to make the train horn go off if it doesn't have to. So we can create a new group chat, and I'm going to call it Training Workshop. If I can. Training Workshop. And I say OK. And now I've got this new tab, and I'm the only one here. The operator's not in this conversation, so I can send a message, testing, and the train horn did not go off. So this can be really useful. I can edit membership. I can add everyone here. I can add you all to this training workshop conversation. We're training. If you're logged in, feel free to send messages. So if something goes wrong, talk and draw is where the operator will communicate that to you, or they might ask you to abort your script if they see something about to happen. It's also where you can communicate with the next observer. So maybe your script is going to run 30 seconds over time. You'd have to ask the next observer if that is all right. And usually they'll say yes. So this is talk and draw. Now, we're talking a lot about talking, and talk and draw does have a whiteboard feature. I don't know anyone who has ever used it and had a positive, warm, fuzzy feeling about that. It's there if you want to draw a picture for everyone around, but it's not the best whiteboard feature.
It also makes a train horn every time you draw something.
Oh, I didn't know that. That's awful.
So if you're playing tic-tac-toe with your project friend in the all users chat, the operator will hear every circle and X that you draw.
Yeah. So it's talk and draw. We mainly use it for talk. You can also click Get Attention, and that'll make the train horn go off if you're not getting a response from the operator. Our operators are human beings, so sometimes they will get up for a couple minutes to go use the restroom, let someone into the building, fry their chicken because they work 12-hour shifts. So you can use the Get Attention if you haven't had a response for a couple minutes and you really need to hear from them. When you're observing, You'll also have the operator phone number, so you can call the control room. The operator might call you if they are having trouble getting a hold of you. So that's talk and draw. I'm just going to set that to the side there. One of the next most important windows to have open, again, we're going to go to Observer Tools, and we're going to talk about Scheduler and Skyview. It's going to take a little bit to launch. And my apologies if I'm ignoring messages in the chat. I can't see those right now. But I'm sure Dan and Will can handle most questions.
Yeah, Will and I are keeping an eye on it.
Sounds good. Thank you. Okay, so this is Scheduler in Skyview. It's a very nice looking globe of the sky. And we can use this for monitoring what's going on during your observation, but it's most important when you're preparing your scripts and figuring out what is going to be visible. So we can put different coordinate systems on this map of the sky. My personal favorite is equatorial, but everyone's got a preference. Got a couple features marked on the map by default, like the northern galactic pole. This this pink circle with crosshairs is the position of the telescope. We can see the sun, various planets, as well as the galactic plane, and we can toggle all of these on or off. So the main reason that we use Scheduler in Skyview is because we can load catalogs in. Now, by clicking the catalog button up at the top, bringing me to this little menu, I can add or select catalogs. It'll take a sec to load. We've got a bunch of default catalogs, mainly used for pointing. So I'm going to add H1, I'm going to add the H1 Strong catalog. So I just click the name of the catalog, and now it's highlighted green. You can see the default color is this nice dark green color. So I'm going to click Apply. And now all of the sources within that catalog show up on my Scheduler in Skyview. Great. But what if I don't want to observe an H1 source? I want to observe my extra special fancy pulsar. So I can add a user catalog. Dan showed you how to write a user catalog into your script, but you can also create a text file and then just load that text file into your script. So I'm going to use just a script that I've got with a bunch of masers in it. And that is saved in my home area. But you can, go on through the file system and figure out where yours is. Yeah. Now it's mad at me because I navigated away from where the script lives. Okay, there we go. Take another second. So this is highlighted, but I don't want to apply this just yet because I won't be able to tell what's an H1 strong source versus what's one of my extra special masers. So you click default color and pick your favorite color. I wouldn't recommend the blue colors because they don't really show up well against the background, but your choice. So now default color is pink. I can click apply and then just OK. And you might notice that not much changed, and that's because these sources aren't visible currently. Okay, that's a problem. But what if my observation is scheduled at a different date and time? I can Right now this is set to just the current date and time, so November 4th, UT 16, whatever. I can change the date and time by just clicking the Change Date Time button. So maybe I'm scheduled for the 12th at UT 7. I can click Accept New Date and Time, and this entire map will shift to reflect the state of the sky at that point in time. Great, now my sources are visible. How long are they going to be visible for? I don't know. I can use this increment button up here to change things by an hour, and I can keep going, and they'll be visible until they're off the screen. So at that point, they're right on the edge of what the GBT can see, so they would be setting. Any questions so far on how to use Scheduler in Skyview? Alrighty. I'm going to click Change Date and Time, and I'm going to click Now. And then Accept New Date and Time, and that just returns us to the current time. You can hover your mouse over different positions and see in the lower right corner things like latitude, longitude, HA, azimuth, dec, and elevation. So the GBT does have elevation limits for observing. We can't look right at the horizon. We've got things like trees and mountains in the way. And if your source is particularly high elevation, sometimes you'll hit what's called the keyhole, where the source is actually moving faster than the telescope can track. So elevation is something just to keep an eye on. This is all in the Schedule tab. Now, if we go to the Real-Time tab, that'll show us what the telescope is looking at and doing right now. So this is useful to have open during your observations. So you can see, telescope is here right now, but maybe I want it to go to a source down here. You would actually be able to see it move in real time. So that's Scheduler in Skyview. The most important thing there is adding your catalogs and planning for your observations. So I'm just going to minimize that and close out of that. Alrighty, so our next Cleo application is going to be our status window. This is like the window that Dan showed you in Astrid, but it's a lot more detailed. It might take a minute to load because it has so much information contained within it. Now, a fun little fact about Cleo is that it's got this fun, nifty acronym, Control Library for Engineers and Operators, but Cleo was actually named after the cat owned by the person who developed it. So there's a couple Easter eggs hidden throughout Cleo, where if you type a certain word, pictures of this cat will show up. So if we've got time later, we might go through some of those. Almost there. It'll take another minute for information to populate. There's a lot going on here, so we are going to talk through it sort of panel by panel. So in this top left panel, we've got our devices, and we've got their different statuses, and we've got their different states. So When you're observing, you'll be using the antenna, as well as all of the electronics that make up our signal path. So that's things like the local oscillator, the IF rack, quadrant detector, IF manager, all of that. And you'll also see whatever receiver you're using. So right now Dave is using a C-band receiver, and he's using the DCR backend. So you want to make sure that the devices list matches what you'd expect. Then we've got the status window. That tells us that the antenna and the quadrant detector are both in an error state. If I had to guess, the quadrant detector probably is a low power error. Not sure what the antenna error is. An error doesn't necessarily mean you have to stop observing. For instance, Dave is actively running scans right now. If you are in doubt, you can ask the operator what the error message is and whether it's something that you should be concerned about. They are at the telescope for 12-hour shifts. They know the telescope inside and out. They know what various common errors are, as well as ones that are new and might be concerning. The operator generally will not be able to fix whatever problem you're having, but they will call me or Dan or Will or one of the other scientists on site, depending on who's on call. And we will get online and we'll troubleshoot. We might be able to fix it. We might say, this is an electronics issue, or this is a software issue, or this is a mechanical issue. So we'll troubleshoot further, kind of triage, and determine who gets the next phone call. Never feel bad about asking a question or asking if you should be concerned about something. Don't feel bad if you have to call us at 3 a.m. We know what we signed up for. The state just lets you know what that device is doing right now. While you're taking a scan, everything will be in the running state. But basically things will go from idle to initializing to ready to running. So you can see, maybe the antenna is taking a little bit longer to boot up, even though everything else is ready. A scan won't start until everything is ready and running. You can also see a nice little clock up here, our LST, that's the local sidereal time, as well as UT. So that's the top left panel. Top right panel is information about whatever we're telling the telescope to do. So whatever we've named the source in our catalog, what scan number we're on. So Dave is running a very long session right now doing, I believe, pointing scans. So he's taking measurements of the track to make sure that the telescope, that we have an accurate model of where the telescope is pointing. And we do that fairly regularly. We've got the project code. For us, that would be TGBT 25B608. The switching signal master. Right now, signals are being switched through the DCR backend. The start and the length of the scan. So Dave is going to be doing a 60-second scan. That makes sense. That's probably why his scan number is so high, is he's got a lot of very short scans. We can see who the observer is. We're doing continuum observations. We're doing a total power scan with a calibrator, or with calibration, and you'll learn more about what all of that means in your later talks. We can also see some information about the frequencies we're observing at. We're at C-band, so rest frequency of 5 gigahertz. Seems pretty standard. Now, going on to these middle panels here, the time to set, that's how long our source is expected to be up. So we've got another 6 hours on this source if we want. As well as our azimuth and elevation positions. So indicated means where we actually are on the sky. Commanded is where we want to be. Rate is how quickly we're moving. And we can see difference in error terms there. Generally not something you'll be paying super close attention to, but it's fun to be able to see the telescope move. Now this middle right-hand panel has a lot of information, so it's very dense. But we can see that we'll be on target in about 2 seconds, and now we're on source. We can see that our indicated and commanded positions match pretty closely, so that is a nice little confirmation. Axis fault and e-stop, that would be lit up if our telescope had moved into a hard stop limit, or if someone had pressed an e-stop button on the telescope. No one is on the telescope while we observe, but sometimes the e-stop gets pushed during maintenance by mistake. Now we've also got our as local pointing corrections and our elevation local pointing corrections. So that's just saying, we know that we are off by this much, so we're going to add this much to make sure that we're on source. And we get those numbers by doing our pointing scans at the beginning of a scan. Especially at higher frequencies where your beam is pretty small and your pointing is strongly affected by wind, we recommend that you point and focus the telescope quite often. At lower frequencies, the beam is much larger and you're a lot less susceptible to wind, so you don't need to point as often, but you definitely still should point and focus at the start of your observation. We've got our focus corrections in these boxes here, and we're using the 6C pointing model. That's our latest model. You won't ever have to adjust these values, they're just there for your information. We've also got some weather information here. So this bar here is wind speed, actually. So the red zone is danger. We will not be observing in the red zone. Orange is not ideal, but we will probably keep observing through orange. Yellow is like the lightest level of warning. We can see right now our wind levels are pretty low. We can also see our sort of historical wind speeds. So this thick blue line is the average wind speed over the last minute. We can also see our maximum wind speed and our minimum wind speeds, or our maximum wind speed and our current wind speed, excuse me. And these triangles show the sort of peak wind speed for the different weather stations. We've got 3 weather stations at different elevations on the telescope. We can control what we're looking at in these boxes here, what units we're using. So our main wind and temperature stations. Maybe we like our wind in miles per hour. Maybe we like kilometers per hour. Default is kilometers per second. Default is Celsius. We can also change it to Fahrenheit. I think it would be neat if we had Kelvin, but I didn't write this software. And this view here is like an inverted Sketcher sky view. So it shows you position. It doesn't show you catalog information. It just shows you where you are and where you told the telescope to be. So down here, we've got a lot more detailed information about our telescope settings. So we've got the central frequency of our local oscillator. We've got the different temperatures of the different stages of our receiver. These flickering boxes here are our noise diodes. So we want them to be flickering. So when we see the little green light show up briefly and then disappear for a while, that's good. We've got power levels coming out of the optical driver, various information about where our signal is being routed, as well as information about the active surface. As an observer, you probably won't be paying too close attention to this, but it will come in handy if there's troubleshooting. So the on-call scientist might look and see, oh wow, there's no power going through the optical drivers. That's a clue. Our IF manager similarly tells us how various devices are configured, as well as the signal path that has been configured. Messages. So this will be a standalone Cleo window, but you also get a little sampling here of various warnings and messages coming in. Any questions on the status window? All right, we're moving right along. So next up, we're going to look at messages. And this one will absolutely take a minute to load, because the GBT produces a lot of messages during an observation. Yeah, Lucy, you asked about high frequencies pointing and focusing more often. That's a good question for your project friend, which I'm realizing is me, for you in particular. It depends. We've got a table by receiver for what's recommended. I believe every hour is recommended for the highest frequencies. Every couple of hours is recommended for the lowest frequencies. Okay, so we've got our messages window here, and we've got a lot of messages. So let's go through some of them. Right up here, we've got the scan coordinator. So that usually is just informational message about what the telescope is doing. So that's telling us we just started scan number 223. And as soon as a certain amount of time passed, that message was no longer relevant. You might have noticed that, the background disappeared. So it's highlighted yellow right now, but once the next scan starts, it'll have no highlight. We've also got an IF rack message. It doesn't have a colored background, so that tells me that that message has cleared, so it no longer applies. Quadrant detector, low beam power. This happens a lot when it's overcast or cloudy. It just means that we're shooting a laser at a sensor, and we're not getting as much power from the laser as we'd expect, maybe because there's fog in the way. I know that they've been realigning the quadrant detector, so that might have something to do with it. We're also seeing a lot of messages for receiver MBA 1.5. We can ignore those. We are not using that receiver, so those are just kind of there for information. Looks like we've got a structural temperature sensor issue. I recognize this one. We've been having issues with this sensor, so our electronics division is aware. All of these are at the level of information or warning, except for the quadrant detector. Let's see, this looks like a communication error. That is an error. So that's still not the highest level of problem that could be reported here. Again, I know that we're aware of all of these issues and that we've been doing some work on them. So a lot of messages will pop up. You can ask the operator if you should be concerned about any of them. But in general, if you see a message related to your receiver, that's a good one to ask the operator about. You can filter as well which devices you're looking at. So if I was like, I don't care about Mustang, I could filter out all of these Mustang messages. You can also, remove any cleared messages. So this is where you'd go for just more details. Any questions thus far on messages or anything else I've talked about? Alrighty. Okay. I'm going to show you two more Cleo, features, and then we'll see what's next. So we've got an application for just about every system on the telescope. And for the most part, you are not going to have all of those open. You won't need to look at the signal path while you're observing. You won't need to look at the backends that you're not using. But if you are using Vegas, we do recommend having some Vegas windows open so that you can keep track of power levels coming into Vegas. And this will also take a bit to load. And Dave's not using Vegas right now, so it's just going to have noise. But you'll get to see Vegas when you're observing. So one of the special things about the GPT is that you can have multiple observing windows at once, routed to multiple different banks. So different banks of Vegas just means you're recording data from multiple different streams. And so those banks are labeled A through H, and we can see what mode they're configured for, the bandwidth they've got, whether there's a noise source or a test tone, what kind of polarization we've got going on, all of that information. So all of these banks of Vegas right now are in the ready state. So if Dave wanted to submit a scan using Vegas, he could, but they're not currently being used. And here we've got power. So all of them are around -40 dB. When you are actually taking data, you want them to be around -20 dB. So we've got this window, but some of us like looking at graphs and pictures instead. So that's where the Vegas power monitor is useful. And that will also take a minute to load. Alrighty, so here's our Vegas power monitor, and we can see the histogram of the power values in counts. So this is how many power values we've got, and we want this to be about 20 dB wide. So that's one thing you can check. What we really look at is this chart here. It's just like a chart recorder showing power levels in the two different channels. So again, -36 to -40 dB. That's fine because we're not taking data, but you'd want to see around -20. You can go bank by bank. So depending on how your observation's configured, you might only be using bank A. You can also see all of the banks at once. So this is useful to have up. Any questions about Vegas or Vegas Power Monitor? If you're a pulsar observer, there will be a couple windows that you might have open that I'm not going to go through during this session, but talk to your project friend and you'll see when you're observing. Now I've told you that there are a lot of windows you should have open, and right now I'm in the office, so I've got a nice big monitor, I've got a gorgeous screen. But when it's 3 a.m. and I'm observing, I'm on my laptop at home. So Cleo has this useful feature called the Cleo container. I'm going to close out the windows I've got open currently because they can slow down the system. So Cleo container is basically just a way to have all of your windows in one nice neat place. So from within Cleo container, I can launch scheduler and Skyview. Yeah, I'll launch a copy. And again, it'll take a minute to load. So I can do everything that I would do with the scheduler and Skyview application standalone from within this container. Okay, what if I want to look at the status window? Yes, I can have that open in the Cleo container as well, so that I can just switch between these two tabs pretty easily. I can have some things in a Cleo container and some things launched as standalone. Everyone has an observing setup that they prefer. So as you get experience observing, you'll rearrange your windows differently, just depending on what works best for you. Of course, I picked like the two most intensive applications to open as demo, but yeah. So that's most of Cleo. Any questions about Cleo or about some of the other windows that we didn't go through? I'm sorry that everyone's been having some connection issues, but I'm glad we're able to troubleshoot.
I think that everyone is now able to connect. If I'm wrong, please send me a message. We've been working furiously in the background to fix some things.
Thank you, Will.
Yeah. Any other questions for Dan or Jay on Astrid or Cleo? We'll have a little bit more background after lunch for the computing system in general, network access, and then data reduction. But you'll be using these systems to interact with the telescope during your observation sessions. So we'll open it up for now. If anyone has any questions or comments, please go ahead and unmute or throw a question in the chat. Go ahead, Joe.
So the Clio container is pretty cool. Can you save like particular layouts and things like that, or do you have to make it every time?
I believe you can save, not necessarily a layout, but I think you can save, so let's see. I maybe shouldn't have stopped sharing my screen. That's fine. I think that using multi-launch, you can configure which applications you want to launch from Cleo. So you can get into that. I think the links I sent, yeah. Okay. So I don't have any multi-launch configurations saved, so there's nothing for me to really look for, but that is something you can definitely configure. I believe the Read the Docs link I sent has some more information, like has links to the Clio manuals and stuff that probably would be able to walk you through that.
Any other questions? Okay, great. Thank you so much, Jay and Dan, for walking us through those systems. If you are still having issues connecting, please hang around, shoot me a message here. I'll hang around for about 10 minutes or so. But otherwise, we have about 70 minutes before the final session for today, when we'll talk about the Green Bank computing systems and then data reduction. processes for Spectral Line, Pulsar, and Mustang. And yeah, thank you very much, Jay. Please terminate your FastX sessions. I put in the chat. Turns out that NREO wide, so Greenbank, Charlottesville, and Socorro, we have 70 licenses total. So we are effectively using half of the licenses just through this workshop. Some of our computing folks went and got rid of some stale sessions that had been just lingering for about a week. So yeah, please terminate your FastX sessions now, and then you can reopen them later. And between your observation sessions, again, just get rid of them so that if people need to access VLA data, they can. Or Greenbank data, or Alma data, right? Cool. I will stick around, and thanks again, Jay and Dan.